Hello everyone, welcome to my YouTube channel, The Learning Hub. In the previous video, we have done the implementation of k-nearest neighbor in Python, and then we have discussed about Weiss theorem, and then we have discussed about naive Bayes classifier for the purpose of classification. We have done a complete example for solving the problem of naive Bayes classification. And in this video we are going to discuss about the implementation of naive Bayes theorem in Python. So let's see what is there in naive Bayes Python. So as we have already done k nearest neighbor, as we can see, we have done this in the previous video. If you have not gone through it, I suggest you to go through it once. So approximate 80% program will remain same in this case, like numpy pandas. We will read the csv file, we will print the head, we will drop the id column. So all which the same will be done, so I'm not going to that much detail in this case. So just have a quick look at this. So these are the libraries that we have to import, just like in knn we have done. Then we will read the dataset iris, and we can see in this iris dataset, if we print the head, we are getting one additional column id. We need to remove that. So we will simply remove this by using the drop command. So this is the same code as we have done in k nearest neighbor, so I'm not going into this much detail again and again. So this is the same thing as we have done in k nearest neighbor. As we can see, in k nearest neighbor we have removed the last species column for the y1, and then in the y we have picked the 4. So that is the same thing when we do. So here we know that this column stands for all. Simply it means all. So when we write x equal to df dot I location colon comma colon -1, so it means all rows, because the first attribute specifies all the rows and it is specifying columns. So it will pick all the rows. And what -1 here means, before writing -1 we have written colon, it means all the columns, but we have written -1, it means all the columns excluding the last column. So that is the last column. When we exclude, that is one column we exclude, species will be excluded. And similarly here we have written in y we have picked column, that is all the rows. And what we have done over here, 4, that is all the 4 columns we have picked, the first 4 columns. So if we write minus and we specify anything with minus, it means the 2 columns will be dropped in that case. Fine. Whatever we have specified the value, -1 will drop the 1 column. If we write -2, 2 columns will be dropped. And if we don't write -1 over here, we simply write 1 over here. What does it mean? It means, in this case, it means pick the first column with the index value first. So we simply want to remove the last column over here, this one species column. So we will write -1. And here we have not mentioned any minus or any column. It means if we are specifying 4, it means 4 columns to be picked. That is sepal length, sepal width, petal length and petal width. So we can see id we have already dropped. We are not having id column in this case. So the 4 will be sepal length, sepal width, petal length and petal width. When we print this code, let's have a look at this. What is there in x? We will print x for that. So we can see species has been excluded because we have used -1. Similarly, after this, let's see what is there in y. So when we run this, we can see the species, the last species column is being coming in this case. Then this is the same thing as we have done in linear regression and knn. We will from the model selection we will use train test split, and we will pick all we will separate the database with a test size of 20 and training size of 80, and will be stored in x test, x train, y test and y train. So once this is done, the next thing that we have done in knn similar to that, that is doing the scaling. Fine. So we have done scaling in logistic regression also, we have done scaling in knn also. So this is the same code. Fine. So we will do that. Now scaling has been done so that they are at same magnitude. Now next thing is, after scaling we have to use the naive Bayes. So for implementation of naive Bayes, what we need to do is, we can see from sklearn.naive Bayes here. This is the only part that is different from knn. Rest all the practical, the complete practical is same as in knn. So here we say sklearn.navbase, we will import the Gaussian navbase, in this case Gaussian NB, then we will call that, and we will fit the model for on the training data X-train and Y-train, we will fit this navbase model. Simply run this. And once this is done, now our model is ready. We can use this model, this NB model. We have given the name NB to the model. We can use this NB to make the prediction. So we use NB.predict. Accuracy score we have imported from sklearn matrix to see the accuracy in the prediction. So we will do that now. Let's see the prediction accuracy in this case is 93%. And we will simply use the prediction, so we can see these are the predicted values for the test data. And once this is done, we can see just like we have done in KNN at the last stage, as we have printed this confusion matrix in KNN also. So same thing we are doing over here. So I'm not repeating all that code again. It is simply printing the classification report and simply printing the confusion matrix. So when we run this, we will get this. In this case, we can see there are two values that are being wrongly predicted, meaning all data items have been accurately predicted. So that's all about navbase. As we have seen, this is not much different from KNN. We just are performing one change in this case in the code. The only change in the code is here we in KNN we have imported k nearest neighbor over here. So here, and this was same in k nearest neighbor, we used we imported k nearest neighbor classifier, and we use that by specifying k value equal to 5. In this case, we are importing Gaussian NB, and we have used that Gaussian NB. This is the only difference that we need to make the change in this. As we have seen in the previous video of naive and Bayes theorem, that we are performing long calculations to do classification, but when we write the code in Python, it is a very short code. So this is not a complex code, very easy code to understand. So I hope it's clear to you. But if you are having any doubt, I must suggest you just watch k nearest neighbor implementation in Python, linear and logistic regression implementation in Python once. Also, for understanding the working of this Naive algorithm, you must understand the theoretical concept of this. So thanks for watching the video. Stay tuned for the upcoming videos on the latest topics. So thanks once again.